Welcome to the virtual part of CHM230 Lab, the Introductory Organic Chemistry Lab. And typically the first lab we do is on the properties of compounds. And if you're going to work with a compound, you're going to handle it, it's very, very important to know its properties. If you're going to try to extract it into a solvent, you need to know its solubility. If you might be heating with a flame, you need to know its flammability. It's good to know what it looks like, so that if you open the bottle and look in there and it's not the right color or not the right physical state, then you'll know that something has somehow happened with this. And so it's very important to know how to record and observe and work with the properties of different compounds. And so here we normally would do the first lab to determine some of the properties of different compounds and to observe them and sort of set the stage for working with compounds during the semester. Many people make a distinction between organic and inorganic compounds, like all inorganic compounds are the same as each other and very different from organic, but I find that to be sort of an antiquated categorization, because although most organic compounds are flammable, hydrocarbons especially, many aren't. And although many inorganic compounds are not flammable, like salts, but some inorganic chemicals are so flammable they burst into flames upon exposure to air. And they've got a particular word for that, pyrophoric. So a lot of people who worked early on with silanes and things along those lines found that the inorganic compounds were extremely flammable and caused accidents in the lab. So it's a good idea just not to have any general preconceptions, but just to study compounds one by one and to figure out how things are put together, how they react, and etc. So in this experiment, we would normally record physical and chemical properties of several compounds. Flammability, solubility, density, and melting point are important properties that affect how we deal with chemicals in the labs. The lab you actually do in lab this semester is a melting point lab, but here we're going to talk a little bit through some of the other physical properties, and then in the next recording, the next video I make, I'm going to go ahead and explain some of the observations that you would make in the lab if you were actually doing the lab. Alright, so the other thing that's on this first page in terms of background is about the naming of compounds. So once an organic chemist asked me to go and find methylene chloride. He said we needed methylene chloride and I had to go to the solvent cabinet and get the methylene chloride. And I went and looked, and there was no methylene chloride in there. And so, as far as I was concerned. So then he insisted that we had just gotten some in, and it was in the solvent cabinet. So I went back, and I looked again, and came back and said, no, there's no methylene chloride in there. So he again insisted that I needed to go get the methylene chloride. So I literally pulled every single bottle out of the cabinet, read the label carefully. When I was 100% sure there was no methylene chloride in the solvent cabinet, I went back and told him again. So finally, he was almost at his breaking point with this, but he went over to the cabinet and the first bottle he grabbed said dichloromethane on it, and he said, this is the methylene chloride. And I was like, well, how am I supposed to know? Because it says dichloromethane, which doesn't sound like the same thing as methylene chloride. So one of the things that might take a little while to get used to is there have been several names for certain compounds. There's an old name, a new name, a systematic name, some other common names. And so if you're going to work with the compounds, knowing the different ways that they're named is going to be important. So ethanol is also ethyl alcohol. They're identical. The methylene chloride is the same as dichloromethane. Sodium bicarbonate is the same as sodium hydrogen carbonate. So a lot of times when names are different, the compounds are different. If the names are the same, they're going to be the same, which is good. But sometimes when the names are different, the compound is still the same. Some of the ones you may have seen in the world, muriatic acid, you can buy in a pool supply store, that is concentrated hydrochloric acid. And lye, which you can use to make soap with, is just sodium hydroxide. So some of the important things here, there are certain properties that help us to understand and work with chemicals, and it's very important to get the names and the chemical identities straight. So good background on this lab. Certain safety considerations, we want to avoid accidental exposure of compounds to open flames. One of my favorite warnings is that one because of the word accidental. In this lab we actually try to set things on fire and see whether they burn or not. So it's one of my favorite labs. I've always liked lighting fires and watching them burn in a controlled, safe, non-accidental way. Alright, so first thing we want to look at is just the physical appearance of the substance. And if you're ever asked to give observations of a chemical, there are three things that are the bare minimum of observations. The bare minimum is going to be its physical state, whether it's solid, liquid, or gas, its color, so is it white, is it colorless, is it red, etc., or is it, what's the clarity, can you see through the sample? A lot of times people, when they say something's clear, they think they're telling us it's colorless, but it's not. You can see through things if they're transparent or clear, but it can be clear and blue at the same time. So, and if you've ever gone and priced or bought diamonds, you will know there's a very big difference between clarity and color. They have different ratings in diamond purchasing. The more clear, the better, and the less color, the better for diamonds. And those are different measurements. So whether you can see through it or not, whether it's clear, cloudy, or opaque, are the words you would use to describe the clarity. Again, transparent is clear, translucent is the fancy word for cloudy. If you're talking about color, you have colorless if there's no color, white, blue, red, green, most of us are familiar with color. So the physical appearance, physical state, color, and clarity are very important and should be your minimum observations. If there's anything else, like if you perceive an odor, or if their crystals have a cubic shape or a hexagonal shape, you know, the grain size of the powders could be very important. How viscous the liquid is, if it's a thick liquid that resists flow, that's different than if it's not very viscous and flows easily. So this is something that the more observations the better, and the more descriptive you can be, the better it is for the people who are going to try to understand and follow your work. So certainly if you're asked to observe a compound before or after a chemical reaction, you're going to want to list at least its physical state, color, and clarity. If there's any noticeable odor, shape to crystals, or etc., add those in. So you can see here that normally when we do this lab in person, there's 8 compounds that you observe what they look like, and most of them are clear and colorless liquids, which is very typical for good pure organic compounds. The second thing that we're concerned with is the material going to burn? Is it flammable or not? And again, the descriptions are a lot of times more rich. It's not just does it burn or does it not, but what conditions does it burn under? So something's very flammable, and a lot of times it's good to write what you observe when you try to burn something, because that's again more detailed than just a single word description. So if something ignites easily and burns quickly, leaving no residue, you might say it's very flammable, right? Very flammable. But some things might be still flammable if they're difficult to ignite, but burns well. until maybe a small amount of residue remains. It might be only combustible, meaning you could burn it under certain circumstances, but it doesn't readily burn, is when you need to try to set it on fire, it lights up, but then it smolders out and you need to reignite it to get it to burn. And that's sort of in the similar category to combustible if heated. Some things will only burn if you get them up to higher temperatures and then try to light them. So if you try to light them at room temperature, you don't really see much, but if you heat them up and get them all, primed for burning, then you light them up and they ignite. Again, if you have something that's just combustible and not flammable, it's usually sort of a smoldering, smoky flame, not very efficient. It might go out and need to be reheated. So there's definitely a difference between combustible, where you can get it to burn, versus flammable, where it burns really readily and will continue to burn on its own unless you put it out. And then not flammable is would not burn. Now sometimes when you do the experiment, if you have your flame too hot and you put it on there for a prolonged period of time saying, hey, maybe this is combustible if heated, you can vaporize something that's not flammable. So you don't want to try to heat excessively. What we normally would do for this is take a crucible top. So crucible top is like this, upside down. So there's a little handle, and we put a little bit of compound in the corner of the crucible top, and then bring in a Bunsen burner at an angle and touch the flame to the crucible top. So a lot of times what students would do without direction is take a crucible for burning something, put the compound in the bottom, and then heat from underneath. If you do that, you're just going to find out whether it boils or not. You actually need the flame to touch the substance. So that's why in this lab we've always used the crucible top and have brought the flame in on the side to touch the compound and see if it burns. And again, to see, you also want to put in what other observations you witness. So if the flame is pink, like for lithium nitrate, even if it's not burning, if you touch a flame to lithium nitrate, you're going to see sparks of pink color, which that's a really important observation. If you have a lithium salt, you'll typically see this pink color when you expose it to flame. Flames might be very smoky. Some things leave a residue behind of things that, byproducts of the combustion that do not evaporate, they're left behind. So if you're trying to characterize a compound, you want to take very, very good observations of what happens under what conditions, so that if somebody did the same thing, they would be able to recognize they got the same result. So the ignition test, very good to see whether something's flammable, combustible, or not flammable. And varying degrees there, again, your detailed observations are probably more valuable than just a one-word description. So when you're doing the lab, write exactly what you see clearly enough so somebody else would almost feel like they were there. So in this lab we would test to see if we could burn acetone, dichloromethane, salicylic acid, and potassium bromide, and we want people to record detailed observations. I may later in the lab, just because I really like doing this stuff, try to film some of these ignition tests. If nothing else, I will definitely be just describing what I would see if I tried to burn these compounds. Alright, and part 3, very, very important for if you want to work with compounds. Many of the techniques for purification, extraction, and recrystallization depend very much on the solubility of compounds. So different compounds dissolve in water, and that's typical solubility rules for general chemistry are the solubility in water, but we have other liquids that sometimes can dissolve things. Hexane is a nonpolar organic solvent, has certain properties for dissolving molecules, and the way we would test the solubility is we would get a couple of milliliters of the solvent, and then we put a few drops, a smaller amount, of what we're trying to dissolve, if it's a liquid. If it floats on the top, and you can see the clear barrier between the two liquids, there's some separation there, then it's not soluble and less dense, right? You mix it up really, really, really well, and if rather than dissolving, it just floats to the top, not soluble and less dense. If you put a liquid in, sometimes it's more dense than your solvent and it sinks to the bottom. You can stir it up like crazy and shake it and put it in a vibrational mixture. Sometimes it just separates out again. And so you can see here that if this was your situation, your new liquid that you add in does not dissolve, it just sinks to the bottom. You get clear phase separation between the two liquids, not soluble and more dense than the solvent. If something dissolves, then you won't be able to see the separation at all, because the molecules will have all dispersed themselves really well, and so that's when you'll have something that's soluble. So if you try to put a few drops of liquid in a solvent, it will either dissolve or not, and if it doesn't dissolve, it can either float or sink. So that way we get sort of an idea of the density relative to the density of the solvent, which is a good thing to know. With solids, you throw in a few crystals, the same kind of idea. The crystals can float or sink if they don't dissolve, and if they dissolve, you'll see a nice homogeneous solution. And so for just about any compounds you're going to work with, you're going to want to know what it dissolves in and how much. Now the term that we're not going to use here, because we're not going to test for miscibility, is many people use the term miscible anytime you have liquid dissolving in another liquid. But if you're only throwing a few drops of liquid into a solvent, whether it dissolves or not is whether it's soluble or not. Miscible means soluble in all proportions. So if you could throw a few drops in and they dissolve, that would be soluble to a certain extent. If you threw a few more drops in, they might not dissolve unless it's miscible, and then it'd be soluble in all proportions. So in this lab, we're testing for solubility. We're not going to try all different proportions, so the use of the word miscible would be ill-advised in reporting what our observations here, unless we tried all different combinations of amounts of the two liquids. So that's something in previous courses they say if a liquid dissolves in another liquid, we call it miscible, but to be miscible you have to be soluble in all proportions. So very interesting to see whether things dissolve or not. Again, we have a more detailed procedure here for how much solid you would put in with how much liquid, and agitate it first and look for is there any evidence that it's dissolving, and then whether it dissolves or not is very important. Recording physical properties, whether it's soluble or insoluble. And again, this is a throwback to the, I haven't fixed this yet, but some people say you should use the word miscible or immiscible, but unless you try to dissolve it in all proportions, which we're not doing here, the word miscible is not relevant. So at some point I might actually fix this document, but that's essentially an overview of the lab. We're going to observe what things look like, just looking at them, the observations of state of matter and color and clarity, and anything else that's noteworthy. Then we're going to try to burn a few things, which always exciting. Some things burn, some things don't. And then we're going to try to dissolve a bunch of compounds in different solvents so we can get an idea of the solubility properties. So I wish you guys could do this in person, but you will hopefully learn the importance of this and learn some of the characteristics of some of the molecules as I tell you about them in future videos.